Okay, good morning. Sorry, good afternoon, everyone. Welcome back to the class. Oops. Let me first share my screen. Okay, here we go. So, we have finished. We have finished lecture 4, which is linear regression. Today we'll start lecture 5. So I've already put the data 2D and the 3D data in the lecture notes here. And let me directly open my local ones. Okay, so the topic of lecture 5 today would be data visualization by Matplotlib. And Matplotlib is one of the library. I believe it's one of the most famous library in Python, to just plot those kind of data visualization. First of all, a very, very basic thing, what is data visualization and why do we need to have data visualization? By the name, data visualization is just to show the data, graphic like representation of the data. Be careful that due to this world that we're living, we can plot for at the most 3-dimensional data. This 3-dimensional includes the y. In other words, I can only include at the most 2 features, x1, x2. And of course, by some tricks, sometimes, under some special cases, by some tricks, we can get some higher dimensional data, but by direct representation at most 2D, so I should say 3D, including the y. The main reason for data visualization is, in some cases, if we're not very clear how the data looks like, let's say the data trend, so then we can plot it, and then we will have some intuitive sense to understand how the data looks like. And then we may determine whether we use linear regression or nonlinear regression or something else. And so, as I mentioned, Matplotlib is one of the library. There are many, many libraries. Nowadays, they have some very fancy libraries. These three, especially Seaborn, these two use the most. ggplot, as far as I know, after the pandemic was not that, famous anymore, but they have some many, many super nice new library. Like, I believe one of them is called Manus. A super, super powerful thing. And in YouTube, if you're interested in those kind of math videos, a lot of those math related videos are plotted by that library. If I have time, I will mention it a little bit later in this class. Okay, so first of all, let's have a look at how can we do this. And it is pretty direct. So we just use Matplotlib, and then we're okay. Let me just directly make it. I guess it's better for me just to write code. Anaconda launch. If you have account, you can use that cloud notebook as well, so it's going to be easier. But the one thing I do not like it is because using cloud, you cannot read the local document. And in order to run a local data, you have to, upload the data onto the cloud server. And you may ask why. I don't know, but I'm afraid one reason because it try to let you pay to buy the version because you only have 1 gigabyte or something, and the space is going to be very full very soon, and then you have to pay every month 30 bucks maybe. So that's the thing. For me, I'm just lazy to do it. Okay, this time let's make a lecture 5. Lecture 5. What did I do? Okay, I don't need this one. Let me call it lecture 5 data visualization. What's the name? By Matplotlib, right? By Matplotlib, okay. By Matplotlib. Okay, so basically what you're gonna do is you're gonna import. Sorry, I know the wrong, but I need to put that one a bit up, otherwise I cannot see my screen. Import matplot lib.pyplot as plt. And then we can just plt.plot and then something. So we can basically put a 2 matrix. Let's say I forgot the number. It don't matter. Let me randomly put 1, 2, 3, 4. Let's say 5, 6, 7, 8. And then we can make it something like, for example, plt.x label. Let's say I call it, let's say x. plt dot y label, call it y, plt dot title, let's say hi. Let me use the plot phi1, let's say. And then plt dot show. Do not forget plt dot show. I've seen many beginners say, after everything, why it doesn't show the figure. Let me just, let me show you this one. So if I make like this way and I run it, oh, it still shows now. Why? That's interesting, huh? I'm not sure why it still shows the number. Oh, I cannot use this because if I use this one, it will be really kind of like a linear. Let me make it a very, very non-linear, Let me make it just like this one. Okay, here we go. Let me still. That's interesting because usually PLT does show. That means it's gonna. I mean, you're gonna show it. Anyway, so be careful. This means you're gonna plot. So X is a list or a whatever array you call of 1, 2, 3, 4. That means X equal to 1, X equal to 2, 3, 4, and negative 3 and 4. Y equal to 5, negative 6, 7, and 8. So this will kind of like plot 1, 5. Be careful, okay? It's not 1, 2, 3, 4, but it's a 1, the first X and the first Y, the second X and the second Y. And I'm lazy, please excuse me. I'm just gonna write dot dot, and then 4, negative 8. So it's gonna 1, 5, 2, negative 6, negative 3, 7, and 4, negative 8. And indeed, you can see this is kind of like, let me just, okay, I can do it later because I'm just a bit lazy. So you can put this 1, 2 as, where's 1, 2? 1, 2 is here. And then, well, 1, 5, wait, 1, 5 is here, sorry about it. 1, 5, and then that next number is 2, negative 6, 2, negative 6, from here in order. Here, then here, then here, then here. Of course, you might say, oh my goodness, this is kind of like so ugly. Can I just show the kind of like the dots? Yeah, you can absolutely say. By the way, by default, it's gonna be these things, and then Python will automatically make up to your lines. Okay, but now if I want a dot, so I can make it, let's say, red. O means big dot, so it's gonna be like this way. Or you just write O, it's gonna be why by default is this color, not that color? I don't know. Or you can say, let me see what I use here. Oh, I cannot see it clearly, sorry. Or where it is. Oh, here. Red X. Okay, X is a cross. So R means red, X is a cross. So it's gonna be like this way. By the way, again, to run a cell, you can click this one. Or for me, I just directly click Control Enter. The reason I would like to use Control Enter teaching is because usually I only need to, execute this specific cell. And if you, as it shows, run, in advance, it will be Shift Enter, and it will run all the previous one. For me, I would prefer one by one. So it's kind of like a habit. You are very welcome to just Shift Enter. It doesn't matter. Okay, so this is how we can plot, not print. And I believe this is very straightforward, simple. Yeah, these two are the things. And here, I also set up, let me see what I write. Okay, here also use xlim and ylim. The reason I'm setting up xlim and ylim is means to show the limit of this one, and you can see x is indeed from negative 6 to positive 6, and y is indeed from negative 6 to positive 10. This is exactly what I wrote here, and I can do the similar thing here, which as I can write, for example, like plt dot xlim. This time I can say for example, okay, I'm gonna say negative. Let me still use the same thing. Where is the keyboard? Negative 6 to positive 6, and then I will have plt dot y limit to be, let's say this time let me play something interesting. Let's say y limit is negative 8 to, let's say, positive, let's say 20. That's gonna be very weird. So it's gonna be in this way, you know what I mean? And because my y is negative 8 and the minimum number is negative 8, and you can see this is almost covered. And if I want to say, let's say, suppose I make it about 8 to 10, you know what? It will only show the data here. And now at one, I'm afraid that one showing the data will be just empty. You see what I mean? So that's the thing. Python will automatically set up the view of the plot, but in case you want to have a special angle or special thing, especially in a 3D plot later we will mention in this class, you will see this thing is somewhat important. So this is the thing for the basic plots, 2D plots. Okay, the next time is how can we show those kind of like the functions or something, kind of like different things. So one thing I do want to mention is the NP dot line link space. So, but basically the meaning is the linear space actually. So this means from -10 to +10 generate 41 points with the same distance. So in other words, this is going to be -10, let me see, 20 points. And including 0 itself, that's 141. So it's going to be every 0.5, it's going to be a point. So it will be -10, -9.5, -9, blah, 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 0, and then blah, 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 0.5, 1, 1.5, 2, 2.5, 3, blah, blah, until +10. So these are the numbers it will generate. So this will return an array. So why do I need it? Because think about it. How do I really plot a line? In computer, we know that our screen is actually, discrete by pixels, right? So, I mean, from our eyes, because it's very small, it looks like here, it looks like a line, but actually it's not a line, it's just by pixel. So basically, what we do for a line is just make it very dense. So, make the points very dense, so it looks like a line. So that's the thing. So actually, this was done by this link space or linear space. So you make it how dense you're going to be. So here I don't want to make it too dense to first let you see it and also to save my RAM. So I make it only 41. You can do experiments. So let's say I make it to be for 1 million, let's say, and it's going to be really aligned. Okay, but let me run this one. I need to have my cheat sheet probably. And again, in the command version, click B, so it will insert another cell. Let me insert a lot. I'm just lazy to again. Okay, so here we have we've already imploded Matplotlib here, so I don't have to plot again. So I can just import numpy as MP. By the way, an extremely important thing, as I mentioned the last time, that in order to make this one to kind of like because later we'll use PLT, right? In order to make this one work, you have to execute the cell, otherwise that will be wrong. Let me show you what I mean. So let me just randomly increase a fake one. Okay, so I just want to show this very simple example. Okay, so suppose I have import matplotlib dot pyplot PLT. Let's say I say a equal to 1. It doesn't matter. Okay, so now I do not execute it. So I just directly insert a cell. I didn't, run this cell. Okay, and then, sorry, I should. So I make it to be below. Okay, now here I have import numpy as MP, and then let's say I say x equal to MP dot linear space. Oh my, doesn't count. Okay. Next to 10, 10, 41. And then I'm gonna say, let's say I just plot plt dot plot. Let's say x, let's say 10 times x. Suppose I just want to do like this way, plt dot, let's say show. And then you know what's gonna happen if I execute it. I mean, I press this one, it will execute all the cells. But if I use Control Enter, it will execute only this cell. It will show error. Why? Because it will tell you PLT has not been defined. But the thing is, wait, this one has defined here. How come? Let's do it. Okay, error. Okay, see error. Then PLT is not defined. But why? The key reason because although you've defined here, but you did not run this cell. You know what I mean? You need to run it, or you just use this one. It will run the current cell and all advanced. Then it should be working. Oh, why? Let me see. That's interesting. Anyway, so what I'm gonna do is I will use Control Enter to run this first. Now I'm gonna use Control Enter to run this cell again, and then you will see this correct. This is correct. Okay, so this is just a thing. I mean, I show this one simply just to show this example. Now let's go back to to the thing here. I'm pretty lazy, so I already copy and paste here. Okay, no, I don't have to import NP again. And then we plot what? Let me see. What do we plot? We plot. Oh, okay. So the first thing we plot is a x 0.0.2 times x so plt dot title plot y13. Let me call it 53, whatever. Okay, and then you see it's a line, it's x equal to 0.2x, and you can easily see it's clearly, by the tangent, you can clearly see it's x equal to 0.3. Okay, and now I can actually write all together the second thing. So I'm talking about here. Let me write here. So it is the first thing is this one is one part. Now we're gonna do the second part, which is this one. Okay, now I'm gonna have 0.03 times x as a quadratic function, x squared ds grain scatter, and then let's run it. And you see, so this is the thing. And then I can have x np dot sine x b, and I don't know how to read this, but it's basically a triangle. Usually we make it exponential. So this is the thing. Clear. So this is everything you can just simply plot, but indeed it is for three wait. Indeed it is for zoom the panel. It's not that friendly zoom panel. Anyway, here. Sorry, I forgot to, I should increase, I mean this part includes the GS, the green scatter. So yeah. So this includes three things, and then later you will see we can add a legend, their label equal to whatever thing as well. Let me clear everything first, clear all drawing. So that's the thing. We can have the things here, and let me see what is here. What did I write here? We can equivalent write code in following way, which a power of NumPy array. Wait, I get confused. Oh, okay. So here I directly write x and this is the y, and actually we don't have to. You can write the things outside, which means that you can define y1 equal to this, y2 equal to this, y3 equal to this, and see the change. The changes are here. So I just let me use red color. So instead of here, I first define y1 equal to 0.2x, and then I make it a y1 here. And similar things here, instead of the derivative function here, I can write y2 equal to this, and then y2, and similar for y3, So this is a thing. And because my x is defined as an NP array linear space, so I can directly set y1 equal to this. And the Python will understand it's also an array object instead of something else. So this is the thing. And by the way, we can play something for fun that. Let me clear all the joins. Okay, so now here I have 41, right? What if I make a 4100? See it? It's actually already pretty dense. Here not is because I enforce it to be this. You know what I mean? If you see a sine function and a quadratic function, you see it's already very Not to mention if I make it like this way, it's isn't it actually no difference. From the line. So basically this is the same. Or if I make it R dot, the small dot, and it will see something similar, see it? So that's how we make a linear space. But basically, usually for our experiments, I mean, you just make a small number to save your RAM. Okay, and the next thing is I'm gonna show how to include this legend. Let me just make this one. So here, let me recover it. Do this, and then here, let me make a red. The line. Okay. Now, the thing is, in order to add a legend, we will have to use that thing called a label. And unfortunately, Python does not allow us to write a label, kind of like a 3 lines and write 3 labels together. We can only do it one by one. So this is the thing. So here I can say label equal to the first function. This one is a linear function. And then unfortunately you have to write it again. PLT dot plot X GS and then label equals to, so this is clearly a quadratic function. PLT dot plot, and then finally get a label. This is a sine function. I remember it's not any, yes. And I run it. Okay. Wait. You see the point? I need something called PLT dot legend. And before I clearly remember, if you don't put PLT dot show, the picture won't show. I don't know why. Maybe some new versions so that even if you didn't try PLT dot show, it will show the smart PLT dot legend. Be careful if you don't write it. Here's the result. You see, I defined the 3 labels and it doesn't show anything. But if I add this line, it will show the labels, and you can control the direction where the labels later in lectures. No, I believe lectures 7, when we talk about KNN and those kind of classification methods, you will see how to make your things. But it's actually super simple. So this is the thing. How we can add the legends. Again, for add a label, every time you can just plot one thing instead of many things. Okay, the next thing I remember, is it hard? Yes. So this is an interesting, very hard curve. I assume everybody has seen it before, but what you may not know is actually a love story. So at that time, I assume everybody knows this guy, Descartes. So Descartes is a super famous guy who invented our coordinate system, one of the most famous mathematician in the 17th century. At that time, he tried to date the princess of Sweden, if I remember correctly. But the king is very strict, don't want the daughter date the young guy, poor mathematician. And so the father always check, their letters. So how to do that, the mathematician, Descartes can show his love, but also kind of like the father the king would not discover it. So what he wrote is just a letter and wrote this equation. Rho theta equal to 1 minus sine theta. The king's math is not that good. This is a parametric equation. So he didn't understand what that. He thought they may just be discussing, those kind of mathematics. So he didn't, doubt anything, and they directly sent the letter, passed the letter to the daughter. The princess saw it and immediately understand, because this is a hard curve, and a more beautiful way is here. But at that time, due to the mathematical limitation, at that time they just write this one: rho theta equal to 1 minus sine theta. And here is the thing. Okay, now let's see how can we use Python to plot it. So here, again, here, since in the previous 2 cells I've already imported Matplotlib plus MP. So here I'm just lazy. I'm not gonna plot it again. And again, don't forget that you need to run it. Otherwise, it will not be recognized. So we've already run these. So I'm gonna first generate a theta. By the way, I assume everybody knows the parametric equation. Yes. So this is a more clear form of the parametric equation, which t is a parameter. Here is something similar, but the difference is that I'm gonna run it kind of like in the polar, kind of like the polar coordinate instead of just our xy coordinate here. So let me where it is. Here it is. Okay, so in order to do this, what I need to do is I need to define the theta, because here rho minus sine theta is the thing. So theta should be generated from 0 to 2 pi, right? NP dot length space. Okay, now it's smarter. So from 0 to 2 times NP dot pi. So how many times you want? Let's say, how many do I use here? 100. Okay, let's say 100. And then I can directly have PLT dot plot. No, sorry, because here I'm gonna make the polar system. It is axis, I believe. Yes, axis. Let's say polar equals to truth, and later we'll see something similar, but we will make a projection to be 3D similar things. So PLT dot plot. Here I'm gonna have theta y 1 minus sine NP dot sine theta. There, here we go. PLT dot show. Okay, here we go. You can make it more romantic. Let's say here, I believe I make the color to be red. You know, you can make it more romantic like this. Today is not today. Maybe next year, the Valentine. So you can you can show it like this way. Oh no, it doesn't allow this. Okay. Okay, so this is the thing, and I believe I set up another thing, which is a more beautiful kind of a sign function, a more beautiful heart curve, which is right here. And so this is, you know, again, we use a parametric. So here, I'm just a bit lazy. You know, the code is very straightforward. So here, first of all, I define the t as we just did. And then because I have the t, then I can define the x equal to 16 times np sine t. And this is exponential again, okay? 3 and the y is, you know, everything just mathematics. Mathematics is just, you know, type it inside. And then you make a plt dot plot. Here, be careful, it's not polar system anymore, so you don't need this one. You don't need plt dot axis polar equals to true. You don't need it because it's just, you know, an XY system. Then you just print it and again make the color R show. So this is a very beautiful heart in my personality. And if you're interested, you can even print a 3D. I believe I believe in it's a homework problem or something. I forgot. By the way, once you finish lecture number 6, this is not number 5, right? Number 6, there will be a homework. So in the beginning, I was thinking to have 3 homework assignments plus a midterm exam. Plus a final exam. Later, I realized since this is a very short class, only 6 weeks, we probably cannot have so many homework or midterm exam. I'm thinking to cancel the midterm exam. No worry, I will send everybody an email in case you are not, you know, here. And then we will take 2 to 3 homework assignments and then take our final exams. And as you know, this course only has pass and fail. There's no ABCD. So I hope this is gonna be easier for everyone. That's the thing for the heart curve here. And the next thing I want to show, which is a scatter plot instead of the PYT plot. So people may ask, so since we already have the PLT the plot, why do I need to PLT the scatter? The reason because by PLT the scatter, you can have kind of like a stronger control of different points, scatter plots especially. So let me make it here, the scatter point. Similar thing here, we need to have x. Maybe I can just copy and paste. I'm pretty lazy here. X equal to this, and then I will have let me see here. One sine function, okay. MP dot sine x, and then PLT dot scatter x, y. And the good thing here is that you can define something like marker, label, everything. Here, I can make a marker to be, let's say O. Let me use a dot. Label equal to, again, it's equal to sine function. And then show. Here we go. So dot is a small, kind of a small dot. If we make it to be O, it's a big dot. That's a difference. And then here is the sign, the dot scatter instead of plot. By comparison, I can have more controls, and then we can see the next example. The next example here is kind of like the bubbles. And the interesting thing is that for each bubble, I can control kind of how large it is, what's the color it is. You know, this is something give you more kind of like controls like than the plot. And then we can run it here. I will have let me see here. Let me have a look at it here. Oh, okay. And then I will define 2 other things, which is color, also sizes. By the way, here I'm just lazy. I wrote everything in 1 line. I mean, if you don't want to, you can just remove the column and make it a 4 lines. It doesn't matter. So and then I will have I in range 100 And then I need to import a new library called random. Or I can actually use np.random. Let me just call random. Now I have x dot append. Now I have random dot run rand int but yes, rand int 1 to 100. So what does this do? This is actually to randomly generate an x coordinate. And here y dot append, the same thing. Then I will do what? I will generate a color. Color dot append random, because color is kind of like a continuous function, so I can directly use random, I believe. I don't have to use the int. Size is dot append as well. Size, let's say 1 to let's say also 100. Okay, now you see what? I already have x coordinate, y coordinate, size, and also a color and also size. Once I have this, I can do what? I can just, run plot the things, but I will use scatter instead of plot. I will have x, y, and then z equal to. If you're not sure, you can press Shift and a tab, and you can see here. It's gonna show you, the hint. X and Y are kind of like, the coordinate, and C is the color. So I have a C equal to color, and I believe you will have an S as a size. Yes. Not it don't show what the S mean. S should be the size. Okay, I'm not sure why it doesn't show, but the S should be size. Color and S equal to size. There we go. And now I can really do it. PLT dot show. Uh-oh. Size not defined. Sizes. There we go. And you can see indeed it has so many different things. And oh, in my code I still have an alpha and a color bar. Okay. Also I have this one in 500. So it will be like this way. And then if I want to have a color bar, I can define it here. So this is to show the color bar. And here, sizes, I can make an alpha equal to, let's say, 0.5. So alpha is transparency. It will show you how transparent it's going to be. And you can see, okay, let me just, note the color bar. So there's no color bar, you see what I mean? So, or if I make it to be 0.1, it will be very transparent. Or if I make it to be 0.9, it's almost a non-transparent. Let me keep it to be 0.5, for example. And then also let me enable the color bar. So here we go. And you can see our fors are just used, for generating those kind of random numbers. It's not for, like a plot different points every time. And we just use scatter all done. Think about it. If I just want to use plot to do this, what should I do? I need to write the plot into the for, right? So that's why it's kind of different. And the scatter sometimes is kind of really kind of like easier. A very important thing here, I believe is okay. Yeah, I believe another very important thing is that for scatter it can take kind of like vectors, even kind of like 2D vectors, not only 1D. This is 1D vector or array. Even if 2D, scalar can do it, because later we will do the mesh grid, and it will be something similar. But if you run the plot, it can only take 1D. So if you make it a mesh grid, it will be wrong. Anyway, let's continue to see. The next thing I believe is a subplot. Yes, 2D subplots. So for the 2D subplots, now it's going to be basically plt.subplot. So this is the thing. And then after, so you can just, make it axis, make it a coordinate, make it. I forgot whether 2D has something similar like add a subplot. It may has the add a subplot as well, but I usually prefer this way because if we know we're gonna plot 2D only, this way is more, in my personal view, it's more clear because you can make the axis, so you know which one you're doing now. Then let's have a look at this. Here I will have, let's say, x1 equals to let me see here, x1, x2, but how do I plot sine, cosine? Anyway, in linear space, 0 to pi 100, x2 equals to I believe I copy and pasted. Okay, so I just copy and paste from here. X2 equals to this one. X2. Okay, now I can have figure axis equals to plt dot subplots 2 2. So this tells me that, hey, create subplots which are 2 by 2. And now I will have the what? I will have axis because here I define axis already. So I can have 0 0. So when I make it to be 2 2, it's gonna be like this way. So it's gonna be, we have 4 subplots. And clearly 0 0 will be what? 0 0 will be here. Let me here we go. So this one will be 0 0 0 1 1 0 1 1. So this is the settings. Okay, let me go back here. 0 0 dot plot. What did I plot here? Eclipse, MP naught, and then the second thing is okay, got it. So in order to plot a circle, what should we do? Everybody knows that, for the circle thing, it's nothing but x equal to cosine x. X equal to cosine theta, y equal to sine theta, right? So here our parameter theta is x1. So that I can simply just say here mp dot cosine x1 and then mp dot sine x1. So this is the axis I can make, and I can make it a title 0 0 dot set title a circle. Here we go. But you can see actually because here the height is actually smaller than the length, and hence you can see it's the axes are not equal. So I can say a circle axis not equal. And then how to make it equal? Simple, just add one thing. But no. I just need this one. Now I can have axis 0 1. Similar here, but you just need to add one thing, which is axis 0 1 dot axis equal. So in this case, see, now we enforce it to equal. Now it looks like a real circle, isn't it? This looks more like an eclipse, not a real circle. And then the third thing I want to plot, I remember it was a quadratic function. Where it is here. So x squared plus 2x plus 1. Okay. Axis. I can just copy and paste again, just so lazy to what. X2 squared plus I forgot again. Poor memory. Plus 3x2. 3x2 plus 1. And then this is going to be a quadratic function. Here we go. So this is a quadratic function. And then finally, we plotted a heart there. Let me see. Which is here. Which is right here. But I didn't code it here. So excuse me, I'm gonna be kind of like pretty lazy here, so I'm gonna ignore the fourth plot. But the truth is, you can see this is 0, 0. You see 0, 1, 1, 0, 1, 1. So this is the thing. Let me clear all the joins. Okay, so this is a subplot. And by the way, you can definitely run all those kind of things. You can definitely run all those kind of things in what? In Python, sorry, in PyCharm instead of notebook. The reason I'm using notebook here, just because, kind of like I'm lazy to make it. And sometimes for 3D, you can also make it to be the PyCharm. There's no essential difference, to be honest. The main reason is PyCharm usually for bigger project, and the notebook as a name, Jupyter Notebook as a name is for smaller project, so that it's easier. And later we can use a magic function to make this one kind of independent. And for example, you can see a problem here is that my for example, like, have a look at here, those two things together, right? I wish I could have something kind of like in the PyCharm, I can have a GUI window, right? To enable this, you just need this one. Matplotlib. I believe it's Qt. What's wrong? If and thus cannot be shown. Why not active? Oh, here we go. It's already here. You see? So here I get a GUI window, so we can just make it bigger, then it's gonna be clear. Another method, what you can do is actually make a layout height. So you can actually have something here. You can say, for example, figure dot height something. Height height. Here we go. And then in this case, it will be a bit better. So that will be why it has so many. Sorry, I've opened too many. So here we go. You see, even if it's small, because I use this figure dot layout height, so it makes relatively tight, so it won't kind of like overlap together. Or later, if you prefer to make it go back again, you just make it to be Qt from Qt to inline. Then let me close it. Then it's gonna be put under the cell inline again. Okay, here we go. See what I mean? So this is the thing. Accidentally I pressed twice, I guess. So okay, so this is how we can use the 2D subplot. One thing I need to mention is that, so here I make a subplot 2, but if I make a subplot to be only 1, be careful, it's very easy to make a mistake. So let me just copy and paste here, because I've already defined x1, x2 here, so that sorry. I've already defined them, so I don't need to define it again. Okay, so suppose I want to make this. I want it to be make it 1 row and 2 columns. So I make it like this way, right? So originally we are thinking that it will be okay, and I just run again. The thing is, when you run it, it will show you error. The reason is because of this arrays. So this is something in my personally a very weird setting, that when your subplot is only of 1 row, I guess 1 column the same. I'm not sure. Let me try it. But probably 0, 0, so it's gonna be 0. When it's in this way, yeah, the same here. So when it's only 1 row or 1 column, what gonna happen is that Python would only allow you to here have a 1 dimension array. In other words, you only have x0 and x1. X is 1. You cannot, set up like before we have x is 0, 0, 0, 1, 1, 1, something like 0, 0, and 0, 1. No, it doesn't allow you. It will enforce you to be 1. And that's something weird. Be careful of this, because in some cases we may just need, let's say 1 by 2, 1 by 3, but in this case you cannot use, two like arguments. You can only have 1 argument here. So this is another thing that I want to mention. After this, so don't forget we're still under the topic of linear regression. So after it, I would like to show how can we use this one to do the linear regression. So first of all, let's have a look at the data. The data is let me I can directly let me see. I will have a 2D data first. So by definition, 2D data is two-dimensional. So that you only have y, which is the response and the one feature of x. So okay. Now we have a look at this one. And then the question is, because it's 2D, so you may want to have a look at it. I mean, how, sorry, where it is? And close this one. How does everything look like? Right. Okay. So now what we can do is the following. We can first have a look at the data, just plot the data itself. And then we will observe something, and then we will decide what method to use. Of course, here you only learn linear regression, so of course the data should be, like a linear trend. But later you will learn many different things, like the kernel things. It can be many different shapes. To try to make the code consistent, I believe here, yes, try to make it self-oriented. So I still import all of these things. But the truth is that you do not have to import this because you have already run it before. So let's see, how can I plot the original data first? So I need to import I as np, import let's say pandas as pd, and also I need to import matplotlib pyplot LPLP. Okay, now we have actually, you know what? I'm pretty lazy. I actually don't have to. I have the linear regression things here. I can simply, so this was from last class, remember it? I can simply copy and paste and copy and paste something here. Yeah, this is the thing that I plan to copy and paste. Here we go. But this thing is gonna be different. I hate it. The zoom things, the zoom here, the bars covers everything. Okay. So I need to change the path name. And also, I believe this is 2D, no longer 6D. And here I can just do everything like this way. And then here, we are gonna plot the observed data. Let's say all the observed data. So, and then what we're gonna do is just plot the PLT. Now, feel free to use scatter at that roll rate, doesn't matter. And then let me use, I believe BO, yes, BO. Label equal to the observed data. Sorry for wrong spelling. And then use plt dot plot no, dot x label y, and then give it title. Let's say plt dot title equal what should we call it? Let's say the first observation. First observation on the trend of the observed data. plt dot show. Okay, here we go. And you can see, indeed, it looks like the linear trend, right? So now it shows a clear linear trend. Okay, this one, come here. Okay, here we go. Sorry, the zoom sidebar, the panel, it's just always hide. Okay, we can clearly see it should be something like a line around this direction. Then we decide to run the linear regression. Okay, now how can we run the linear regression? Remember, we've already done it before, which is which is right here. We've already done the linear regression before here. Let me clear all drawings again. So that to save my time, I'm gonna just directly, I'm gonna directly copy and paste and based on this one. And then again, let me insert me. Please allow me to use another cell because I just want to make it kind of a step 1, step 2, make it looks like clear. But again, I need to remake this path again. Okay, and here the 2D. Okay, now this code is what? This code is nothing but the linear regression, right? Okay, so for example, we can just run it. So here we go. This is just, I'm lazy to so that I'm using the code from the previous lecture 4. And then in the following, we can what? We can actually plot the training data, the test data, and also the trend, the prediction function, right? Don't forget here that I've already split the data to be training data and then test the data. Okay, so we can plot them, respectively on the same plot, on the same figure, so that let's say in the following, we are gonna let's say plot the training data, the test data, and the predicted linear, let's say prediction line. The reason it's a line is because it's a linear function and it's in 2D. So of course it's a line. If it's a 3D, then it's gonna be a plane. Okay, now how can we plot it? Super, super simple, right? You just need to let me copy and paste. Yeah, I basically just need to do something like this. But I need to change it a little bit. It's not gonna be the first observation. It will be, let's say, it's gonna be like this. Okay, and then I have the x plt.x label x. Oh my goodness, I even didn't. I even. That's why you can see there's a y, but there's no x. Okay, let me rerun it. Where's the x, by the way? Oops. Okay, here we have the x and y, and here similar, but here I need to plot the training data, x train, y train. And then let's use the training data to be, the BO, again, the training data. And then I will have the what, the test data. The test data, I can use, for example, like the black cross, and then the test data. Let's run it. You can see it is indeed like let me put it outside. Use the magic function. Matplotlib, and then Qt. Ah, Matplotlib. Sorry, where it is. PLT.show and non-inactive. I don't know why it's not inactive. Or it may take some time. It may need some time to plot it. Let me see. That's interesting. Why don't it plot it? I'm not sure. Let me just. It's not active, but it is active. The warning figure versus not inactive and thus cannot be shown. Oh, let me turn this one off. I'm not sure why it's not shown, but let me do this. Let me temporarily just close and let me just close this window, and then let me just reopen it. Sometimes it can be something like that. Okay. The bad point, however, is oh no, it doesn't matter because I will for each cell it's kind of self-oriented, so that I should be still be able to let me see. Okay, so I've not put this one here. Not sure it working. What? Still not working. That's interesting. Why? Looks like there's something wrong with the Matplotlib. I'm not sure, and that's cannot be shown. I'm not sure why this one doesn't work here. Status idle. What? But why the status is idle? Let me do this. Sorry about this, but I will need to. I will need to restart the Jupyter notebook. Sometimes it's kind of weird. Let me see. Yeah, because it shows the Python. It's kind of like okay, here we go. Click here to go to Jupyter. Okay. Now let me just run a super simple thing. Does it work? Okay, it works. So now this one should be working now. Okay, here we go. But it's still there. And here we can see kind of like the testing. Let me put a legend here. plt.legend. So this is the training data. The cross-X is the test data. And by the way, again, every time you run it, the results, I mean, the test data something, and also this regression results will be different. Why? Again, it's because of here. We randomly split, the observed data to be 70% for the training data and 30% for the test data. So because we randomly select it, so every time you run it, it will be, kind of different. Okay, now we have already plotted the training and the test data. The next one is the most important thing, which is we need to plot what the predicted line, right? In order to make the predicted line, what should we do? So first of all, by the linear regression model here, we have already done what? We have already fit the regression and already have the beta zero, which is model intercept, and we've already had the coefficient. Here coefficient is only one because it's 2D. So intercept and coefficient. So we actually should already have what? Y equals to beta 0 plus beta 1 x, right? But in order to plot it, you need to what? You need to generate those things. So that I'm gonna have like x plot equals to np dot linear space. So in order to find the maximum and minimum thing, I'm not gonna manually find it. Instead, I will have x dot min. So this tells me among all your training, all your observed data, not on even the training data, all your observed data, what is the minimum number? And then all your observed data, what of x, okay, what is your maximum number? So in this case, for sure that I can make all points included in my plotted XY coordinate. And then I can have Y plan as well. So we have had X, which is an array. What shall we make to be Y? We should have Y equal to beta 0 plus beta 1 times X, right? But be careful here, we do not have a beta 0, beta 1, Y 1. Instead of called model dot intercept. Oh, come on. Yeah, because I try to press, okay, here I go. I try to press tab, but it doesn't show me the hint. Sometimes that takes some time. And then also model dot coefficient. Here we only have one, so it makes life very easy. And not x, but xpl. So that's the thing. So now I already have xpl and ypl. What should we do? Plot. plt dot plot xpl ypl. And then I can make it to be red and then label equals to the predicted data. Or the predicted, I should have called it line. Here we go. And you can see that's everything we've already plotted here. Here I use a yellow color. It don't matter. Oh, one more thing. Line width. I can add a line width to make it like wider. So yeah, now it's a bit wider. So that is how and you can see the legend, training data, test data, predicted data. Yeah, it's like this. Or if you can use many different colors, whatever you want. Let's say black triangle. Then it's going to be black triangle, to show your test data and the line. So that's how we do. One thing I do want to mention, I believe I showed in the slide. Yes, here we go. So this looks pretty nice, right? However, in coding, especially if you're later running, working in data science or something, you may want to pack everything to be in a function or in a class. The reasons because now suppose I have one group of data for training. So I have this. So what if I have another group of data? Say I have another document called example 2D.1 or 2D underline 1, 2D underline 2 until 2D underline 100. What would you do? Do you want every time write it again? You don't want it, right? So in order to make our code kind of like more efficient, another reason is more kind of like a safer, because in case several people work together, or in case let's say you write too many codes, it's too easy to make a mistake. So if you pack everything inside, it's going to be much safer. So let's see, how can we make all the things to be in the what in the class. So first of all, I need to define the class. I try to make each model to be a class. So class, let's say linear regression models, well, models. Okay, and then remember how to define class. I need an initial function, right? But for everything, it's going to be belong to the class, so that I can have that indent first. So I can define initial. It doesn't show me self. That's why I like PyCharm. Self. So a very important thing is what? The path. I do need an input path, so that every time if I run a different data, I can just put a path, right? So, okay, now I can put here, excuse me. We can, no, this is gonna be big, sorry. Okay, so now I have the path, so I need to, give me 1 second, where it is? Here. Okay, path. Then I can just have data, but be careful here. I want to save those things because later I can use, let's say, if I suppose, okay, suppose I have a LR1 equal to linear ridge regression models. If I want to have this, then I can write L dot X to indicate the data, right? So that here I will have, and this will be your main, your main thing here, the data the same. This will be your main thing in converting it to a class, because you will just everything's going to be self dot something like this. And here be careful about the indent. I will indent for twice. So if you don't mind, let me first remove all those things, all those kind of like let me just I try to make it concise. So here's self, and here I'll have everything just self dot x train, self dot x test, self dot training, y train, self dot y test. And by the way, here if it's too long, right, I can write like this one. This one is also slash. I don't know the I call it the right hand slash. So because it's in the right, and then you can write it in this way. You know what I mean? So if it's model too long, you can always make it to be different lines. But here, let me make it to be just 2 lines here. Model selection x dot. Here we go. There's another thing I need to set up, which is test size. Test size. And then I will have self dot test size equal to test size. Test size equal to self dot test size. Okay. And I know one question will immediately be, so why do you need to write self dot test size equal to test size? Why don't you directly write test size equal to this test size and to work easier? Sure. But again, remember when we're discussing about the necessity of using class, what if later you write a new function which is to change the test size? So you can define function setup test size, you know what I mean, so that it will be changed. While if you write it to be test size equal to test size, it will forever be your original test size. So it will make a big chaos. So trust me, have a good habit, write those kind of things. It's really, really important. It can avoid a lot of mistakes. Okay, so now I have, again, self.model, self.model.fit, self.xtrain, self.ytrain, and the self.r2, self.model, self.xtrain, and self.ytrain. Okay, and then I have print self.r2, self.model. Here I have, I've already defined here, so self.x, self.model coefficient, self.y predict self.model.predict self.model.x, and then print y test at the same here. And then it's a bit long, let me make it like this way again. Self.y predict. Okay. Now, so this is the initial function. So in the initial function, I here to make it lazy, I'm not gonna put the plot function inside. You can definitely do so if you would like. I would like to define another function called, let's say plotting, plot fitting, let's call it. dot fitting self. Okay, again, let me delete those things. And again, here's gonna self dot. Oh, no. Okay, I decide not to write XP and YPL to be self dot. Why? The reason because when we write self dot something, that means I do want to keep this attribute of the object. Let's say here I create an object called LR1, LR1. That means it's a regression one. I may need to see X, need to see Y, need to see X train, Y train, X test, Y test. We need to see the model, need to see the R2. I may need to use them later. That's why I define self-dot this to indicate it as an attribute. But here, XP and YPL, you see what they are? They're just intermediate variables. You know what I mean? Who cares? I mean, I will never use them probably. So here, I do not write it to be self dot anymore. You know what I mean? Of course, in case you think you may need it later, you can absolutely just write it to be self dot XPL. And the same thing here. I may need to change X or I may need to do something to X. That's why I write self dot X. If you are very sure that you will not need it anymore, you can just write it X. But be careful, the test size would highly recommend you to make it to be self.test size because this is an input parameter. Input parameter, it's very possible you're going to change this. Path, I don't worry because probably I'm not going to change them because path, I'm going to create another objective if I want to change the path. But the test size is too possible for it to change. That's why please, be careful about this. Okay, now we have where we're here. Self dot. I need another thing here. Self dot model, self dot this one. PLY SPLY I'm not gonna print it. I'm not gonna change it. So here we go. So we can run like this. First of all, we do not plot it. Let's see whether anything wrong. Oh, wait, great. Column. Okay, everything looks good. Why? Oh, I added a test function and okay, let me tell you a trick. You can actually write it in this way, 0.3. So what does it mean? That means by default it's 0.3. So in case I forget it, so you see what I mean? So here you can see that I actually should have two arguments, but here I just wrote one. Why? Because this means if this one is omitted, then the test size is going to be 0.3. But what if you don't want a 0.3? Let's say you have test, or you can just directly put 0.2, it doesn't matter. Here we go. As a good, no, as a good habit, because, just in case, let's say, you'd better have test size equal to 0.2. What? Still wrong, why? Single potential inductor is out of test size equal to test size equal to self the test size. Probably some spelling mistakes. Let me see why it's linear regression here. That's interesting, huh? It's not out of bounds. Why it shows out of bounds? Because I did have defined two of them test size equal to test size. I'm not sure why, but let me just be lazy, write something like this. There's probably some typing errors because test size equal to test size equal to self dot test size. Yes, so why it is wrong? Okay, that's why. A very small and hidden mistakes. Here we go. Okay, now everything's correct. So, and again, I mean, you can write test size to be 0.3, and here we go. Because before the reason it'll happen is because I still use y, where it is? I even cannot find my mistake. Here, the length of y. Remember, I ran it twice. I ran it twice. The first time is 0.3. The second time I ran it to be 0.2. 0.2 means 80% of the data is the training data, and only 20 is predict data. While here, I didn't write self.y predict. So the y predict gonna be, kind of like, where's the y predict? Self.y predict is equal to this, and hence it shows, hey, where the y predict. I cannot find this variable, and that's the reason why it shows the error. The index is out of the bound because the variable you cannot find the y predict. It should be self.y predict. So here we go. So first of all, we didn't plot it, and we make it to be 20% of the test data and 80% for training data. And now I can write LR1 dot what's the name of the function? Plot something. Plot fitting. Plot fitting. And then show plot. Here we go. So this is how we can make it to be a class. Again, I mean, in a very small project, you might not see any difference, but trust me, in a big project, you always try to make your things to be packed in functions or classes instead of just like before as what we wrote like this way, because it's really add you a lot of kind of like risks. Okay, so this is the thing about, I believe that's everything about the 2D things. Here the thing is, remember we before we run two steps, which is we first have a look at the trend, and then the trend looks like linear, and then I decide to use a linear function. So here's nothing, just you change all the plot to be subplots, and then you make it a 1/2. Here subplots 1/2, and then here we have axis 0, axis 1. I'm lazy to do it, but basically you just need to add one command, which is this one, line 30, and then you change all the PLT to be axis 0, axis 1, done. So that's the only thing. Okay, so here's everything about the 2D that I want to introduce in this lecture. Any questions? No? Okay, now let's go to the 3D part. As we mentioned, the 2D Matplotlib can do the 3D as well. And actually, if you use some other libraries, it can make it a very, very beautiful for the 2D the same. The reason, again, I'm using 2D for Matplotlib is because it's simple. I would be very direct just because it's simple. We want to make things simple and efficient. So it's a very good choice. So here we can just plot and helix. And it's gonna be, like this. And the mathematical form, parametric equations are just, this is actually super simple. Xt equal to cosine t, yt is equal to sine t is what? It's actually a circle, right? Just a circle. Now what I'm gonna do is that, so on xy plane, it's a circle, and then I have a zt equal to t. That means what? That means kind of like a spring, with the increase of your z-axis, which is this direction, I'm gonna kind of like sorry for my poor plotting, it's gonna be up, so it's gonna be up this direction. So this is a parametric. The only thing we need to care is how to make it in the 3D plot. So okay, let me directly write a code. So all other things are the same, but be careful, it's a 3D, and hence in what we need in the parametric equations, we need three things. To make it consistent, let me import, but the truth is you don't have to import, just because we've already run it before. Import matplotlib.py plot as PLT. And now I have z equals to what? Z equals to I use a z line because I have other points here. So let me use z line equals to let's say np dot linear space 0 I forgot 0 20 1000 20 1000 and then y x. So let me call it just ZL make my life easier. XL equal to np dot sine x sine ZL YL equal to np dot, well, xp is cosine, not sine, sorry. And now I can just plot it AX. This is the key. This line is the key line equal to PLT dot figure dot add subplot. It doesn't show the hint anyway. Projection equal to 3D. So this tells Python, first of all, create a figure and then add a subplot. And you may question that, hey, why do I need to add a subplot? I don't have subplot. I just have one plot here. This is to make it consistent. Later, if you add a subplot, the same thing. You know what I mean? What you're gonna do is something here. You need to write something here, like how many subplots you have. And by default, if I don't write anything here, let's say for example 2 to 1. So 2 to 1 means it's a 2 by 2 subplot, and this is the first one. But if I don't write anything here, I just write projection equal to 3D. That means, well, it's just, one plot. There's no so-called subplot. But as a consistent like the command, it's gonna be like this way. And then I can write this x dot plot xl yl zl. The thing, and I can add a label equal to, let's say, helix line. AX dot legend. Be careful, here's AX dot legend, no longer PLT dot legend. And but here PLT dot show is the same thing, which means finally make me a plot. So here I go, X dot figure dot Edison. Sorry about PLT, not plot. Okay, here I go. And of course you can make it like, let me see here. You can make a yellow color. Let's say could make from a yellow color here. So helix line. And I believe here I also added many points. And the point is just to show you the same thing, which is like what we plotted the 2D here. We can just, we can just plot those things, but be careful. It's pair versus pair. It's -1, 1, 3, 8 instead of, all other things. And here the same thing. Let me just randomly add some numbers because I don't have to remember those column numbers actually. Let me just randomly add some numbers. Let's say x equal to, let's say 1, -2, 3, -4, something. Oh, wait. I need to make the number small. Why? Because you see my coordinate here. It is from -1 to +1 because I don't have the R here. So let me make up things like smaller. Let's say 0.5, -1, 0.3, -0.4, something like that. Let me just plot 4 points, and then y equal to, let's say 0, 0.2, let's say -0.1, 1 for example. And then we'll have a z equal to, let's say whatever. Z can be a bit bigger, right? Yeah, Z can be a bit bigger. -1, let's say +1, -2, +2, how many? 2. Okay, now I can just plot AX dot plot X, Y, Z, and then let me use the RO as well. Label equal to let's say 3D points, let's say. Here we go. And you can see those are the things. But didn't you see one problem, which is these things I cannot kind of rotate it or something. So you have two methods basically. First of all, you can just make it in Python. I believe later I will show the examples in Python just to let you know that you just need to copy and paste. You can have everything. Sorry, in PyCharm, not in Python. You can have everything in PyCharm. Another method is use the method that we just showed, make this one. But I just sometimes, yeah, due to the RAM or something, it may show an error. I have no idea why. It's kind of like pretty weird. So you can just write this one, matplotlib.qt, and you see the difference. The difference is that this one was inline, like we have now. I have not run it yet. Okay, that's why it's yellow. I've not run it, but once I run it, it will show an independent GUI window as it shows here. Let me just run it here. Okay, run it. Oh, why? That's interesting. It shows the error again. Then I will have to restart everything again. Oh, okay, here we go. This time it shows up. Oh my goodness. Okay, and here you can see that I can just rotate it, and I can also if I want here, I can also move it. So I can move it like this. So, and this for 2D not big deal, but for 3D, trust me, it's just really important. in order for you to be able to rotate it, because sometimes we need to observe. Let's say you can see the 4 points are around here, you know what I mean? So that's the thing. And then the next thing I will introduce is also like scatter, similar, everything is similar to the 2D thing. Here, to save me some time, I'm not gonna show the scatter here. But basic points are we just have everything the same, and then X the same. The difference here is that you scatter. I can still show those kind of color. For each point, I have different color, have different size, and if I want, I can show the color bar or something as well. You know what I mean? So it's gonna be more efficient than plot, because if I use plot, how can I make every point different? The only way is I need to make it in a loop, but it's gonna be kind of like less efficient. But this one is more efficient. So this is the thing. One more thing I want to mention is here. I forgot it. This is the thing that I always make a mistake, which is for those kind of axes, we make the title and the labels like this way: set X label instead of X label. Remember plt.x label, right? But X is gonna be set X label. It's gonna be in this way so that I can write it in this way: X dot set Y label Y, and then X dot set Z label. And then similar for the title. Oops. Set title. Whatever the title is called. Let's say plot. I don't know, 5 maybe. Okay. Here we go. X, Y, Z, and the plots. Oh, 5. So that's the thing. It's not just a dot title, dot X label, dot Y label anymore. It's a set. And sometimes I always kind of confuse both of them, but I mean you can just I don't know whether it has dot. Does it have the yeah? Again, I try to oh, okay, here we go. Here we go. I press a tab, but that's kind of like pretty slow, The table key is, again, it's the RAM because, it's an online, but it's a local. I don't know why, because if it's kind of like the Anaconda on the Anaconda, cloud notebooks, I can understand, but here's the local. I don't know why it's so slow. But the truth is, it's, in most of the time, it's gonna be very slow. Okay, so here is a thing. Sometimes this was very important. Here is how we can use scatter. If you're interested, you can just, code this in your computer. To save some time, I'm not gonna code here. The next thing is an exercise, which is to plot the DNA. Here I wrote it in Matplotlib. Reason number one is I try to avoid those things. Sometimes it's going to be an error and then I will have to restart everything again. So I dislike it. Another thing, to be honest, is to let you know that you can actually do this. I mean, exactly the same thing in PyCharm. Here, let me still do the same thing in PyCharm. Okay, do I have a folder here? No, so that I need to create a new project. Okay, I can close this one and then I will have a new project. New project. And it's gonna be a tutorial, the same thing. And no, wait, what is that? That's here. Sorry, the other one is a user when I make for the class. Excuse me. In class. Okay, great. I can use this window, doesn't matter. Okay, here we go. But again, don't forget one thing, that the Python interpreter. This is a very bad point for PyCharm in my personal view. So every time you need to go there in settings, and then you need to go to is it editor, interpreter, project. So you can choose the Python interpreter. And here, as I mentioned, I created this one. So these ones are created for all the teaching in this semester. So, so every time I just choose this one. If I need to add whatever package, I'll only need to add this one instead of every time I add a NumPy, pandas, those kind of things again. So here, I believe I've already added them. Yes, NumPy, pandas, those things are already added. So, okay, now I can do this one. The new Python file, exercise, what's the number? 5.3, I remember. Yeah, 5.3. Okay, first of all, the thing is always you're gonna import all the things. So here, let me just copy and paste. I believe here I just need the pandas and NumPy. I don't need sorry, I just need NumPy and the Matplotlib. I don't need scikit-learn. So we're gonna plot this one, right? Let me have a look at it. So we first need to plot the DNA, the hexes. For the DNA hexes, it's kind of like similar things here, but I believe I adjust it to be 0.5 and a z over 5. Okay. The reason I have Z1, Z1, Z2 is because I have two, yeah, helices. So I have Z1 equal to NP dot main space. You can see actually for the hint, PyCharm is way better. 500, yeah, 500. And then x1 equal, I remember 0.1 times NP dot sine. Let me use cosine. Let's kind of rotate things. Z1 divided by 5. Y1 equal to 0.1 times NP dot sine. Z1 over 5. Okay, so this is to generate let's say helix 1. Then we will generate helix 2. But we don't have to reverse this. Instead, we can directly write like this way, Z2 equal to Z1, because the Z-axis is always going to be the same. And the X and Y, you just reverse them. So you're going to have X2 equal to Y1 and X1, and the Y2 equal to X1. Why? Because if you observe the DNA helix, it's nothing. It's just rotate 90 degrees. And hence, I don't need to write it. I just simply make a sine to be cosine, cosine to be sine. So that's the trick. And now I can plot the helix, right? So now I'm gonna plot the helices, the DNA, the two DNA helices. So again, I have AX equal to PLT dot figure dot add subplot. Even if we don't, again, even if we don't make it, we still use dot sub projection equal to 3D. Okay, now I will have X dot plot. Remember, we already have this one, Y1, X1, Z1, 1. And then I can have the number to be, the color to be red in the first one. And then I can have, let me see. No, I actually don't have to. Yeah. Now, let me have AX dot plot, X2, Y2, Z2, and let me use the blue color. ELP show. The reason I have so much space is because I'm gonna plot something else. So, and I can, let me add a set X label. Let's say X, just copy and paste. Why? Okay, here we go. I can just run it. Okay, here. What's so ugly? Oh, I know why. A very important thing, which is okay. Remember before we set up limit in this slide. In this slide, we where it is. Here we set up X lim, Y lim, and this is the observation of the window. And here similar, we need to stand at a further further point to look at this DNA. That's gonna be better. Another thing is the line width. I didn't have the line width. Okay, so it's gonna be 0.65. Okay. So first of all, let me add the line width. And the same thing here. And then I will set up the X lim and the Y lim. I believe X lim 3D. Yes, X lim 3D. X limit 3D equal to negative 0.65, 0.65. And for the Y, the same thing. So in this case, we can stand a bit further, and hence, the plot will be a bit better. Okay, here we go. And indeed, you can see it's a bit better, right? It's if you see how from this direction, here we go. And this is the two helices. And for plotting DNA, usually what you can see online is they have those kind of chains there. Let me just, you know, DNA. So they have not only the main structure of the helix, but also those kind of chains. So I want to plot these chains. What can we do to plot the chains? So basically, what we need to do is what are those chains? Chains are nothing but from here, one point here to one point here. So here to make life easy, I can always let's say I'm gonna depend on the z-axis because here I don't have a rotation or something. Everything is a very simple version. So I can depend on the z-axis, and then let's say k, numbers of the z, I'm gonna plot a chain. Here I believe I choose every 6 or every 5. 6. Here as every 6, I'm gonna plot a chain, and I set up a line width to be 1, and hence you can get those kind of colors, those kind of chains. You can for sure fix the color, but here I would like to keep the color, make it default by Python to make it look more beautiful, enhance the thing. Okay, now let's code it. So here I have the things here. So I have for I in range of length of, let's say, z1. And here every 6 i's, sorry, every 6 unit of the z, I'm gonna plot a chain, right? So I'm gonna say if x modulo 6 equal to 0, then I'm gonna plot. So how do you plot? Ax dot plot, let's say x1 I, x2 I, and then let me see here why let me think. Wait, is it correct? No, sorry, it's wrong. Because again, this should inside be another array here. So here is gonna be y1i, y2i. So remember, the whole array here is x. The whole array here is y, right? Okay, so this means from x1, y1i to x2, y2i, meaning that I will have a chain from here to here. Okay, and now I will have the z. Z is the simplest. Z is just, z is a z. uh z1i and z2. Actually, it don't matter because your z1i equal to z2i at, it's a really no big deal. Okay, and now I will have make it make it a pretty thing so that excuse me, so that I will have the line width equal to 1. Now let's run it to see what's gonna happen here. You should have a chains. Stop and run, doesn't matter. Okay, so okay, here we go. And now this is DNA with the chains. And you can see indeed, how can I make it bigger? Here, let's just focus on the first part. Okay, so I know it's not beautiful, but at least you can see. So you can see the what here. Let me, oh, no, sorry. Okay, here we go. I can rotate it. You can indeed see. You see, so this angle is kind of in terms of z. Every 6 z's, it will be a chain. Every 6 z's, there's going to be a chain. And again, because there's no rotation and z1 equal to z2, so I can make it this way. Be careful in the real application. If you have a rotation, you need to do a lot of mathematics, work. Here, I'm just lazy. I'm not gonna make it a rotation, 3D matrix, 3x3 matrix, and do the things. No, I just want to save my life, save my life. And so here's the thing. So this is an example of the DNA things. Again, you can run. Feel free to run it in the PyChart. Sorry, in the Jupyter notebook. The only thing I'm scary of is this kind of error. So in PyCharm, I can always avoid this kind of errors. I don't worry. So that's the reason why I use PyCharm for many of those kind of 3D plots. And the next thing I want to introduce is the mesh grid function. Mesh grid, if you have used other kind of like Matlab or other language plotting those kind of 3D things, I guess you will be pretty familiar with the mesh grid. It is the basic. It's actually like the linear function, linear space function in 2D. So for a linear function in 2D, remember what we did here? Let me just randomly put a line here. Excuse me. So here, let's say I want to get this line. So first of all, I generated the x. I make the x span from -10 to +10. I make 41 points, right? And then based on the x, I can substitute x to y1. Let's say y1 equal to 0.2x, so that I get all the y's, right? Okay, similar things for the 3D plot. For a 3D plot, let me show you a surface. Later, I will have it. Let's say a surface. Let's say a surface. What I'm going to do here is that I will generate, you know, in the whole. Let me see. Can I? Okay. So in the whole, this plane. Let me. Okay, zoom, please. Let me plot. Okay, this whole XY plane. You know, I will generate what? I will generate different points here. Zoom, let me see how, okay. Let me use another color. Let me use, let's say, yellow color. I'm gonna generate those, not clear. Let me use another color. Let me use a red color. Okay. I'm gonna generate those kind of points, you know what I mean? I'm gonna generate points like this. Sorry. Let me try to make it, you know, at a cross. I'm gonna generate those kind of points, you know, here. So that with these x and y points, I just need to substitute x, y to my z function so that I can you know, get the whole surface, right? So this is the point of mesh grid. So basically, a mesh grid is exactly the same thing as the linear space function in 2D. But in 3D, you cannot, you know, you need the whole plane and then project onto your surface. So that's the meaning. Okay, where it is. So let's do an example here. So suppose my x and y is 1, 2, 3, 4. Let me just do it. Let me go back here again. So suppose x equal to 1, 2, 3, and y equal to 4, 5. 4, 5. So now if I print x and y, it's you know, it's pretty direct. X equal to x, y equal to y. I guess everybody knows the result. It's a very simple. Okay. Now, what if I make to be mesh grid, which is, let me use xy equal to mp dot mesh grid. Oh, sorry. The keyboard xy. Okay. Now I'm gonna print, let's say, xx equal to xx. yy equal to yy. You see the difference? X becomes a what happened here? Let me see. Let me. It's not that clear. Sorry about it, because it makes like you know, y is this one 4, 4, and 5, 5. Let me just print, you know, not to be so lazy. Let me print in 2 lines. Y equal to y. Yeah, this is correct. What is wrong? Eh? Hmm? Oh, I know why. I forgot to close it here. Okay, print. Okay, here we go. So you see x becomes 1, 2, 3, 1, 2, 3, and the y becomes 4, 4, 4, 5, 5, 5. Why? What does it mean? Because, okay, so our x is just 1, 2, 3. My y's are 4 and 5, right? Okay, so y equal to np dot mesh grid xy. That means I simply just kind of like repeat it. So I will, for each x, I will get corresponding for each y. In other words, for my x equal to 1, what I'm gonna have is 1, 4. Wait. 1, 4 is here. This is 4. 1, 4, and a 1, 5. You see it? For x equal to 2, it is what? 2, 4, and a 2, 5. X equal to 3, 3, 4, 3, 5. I want to have things like this way. And hence, I need what? I need totally, you know, 3 elements times 2 elements. Total, I want to generate 6 points. right? In order to make it like a linked space, in order to make it possible, what shall I do? I should have for the y's to the first, I mean, it's right here. Oh, the zoom, where's the panel here? So I cannot find the zoom panel here. Wait. Oh, it's here. The zoom panel is kind of like not designed so friendly in my personal view. Okay, so I will have my axis to be 1, 2, 3, and then my y's to be 4, 4, 4. Then if I'm gonna plot, what's gonna happen? It's gonna be 1, 4, 2, 4. It's gonna be 1, 4, 2, 4, and the 3, 4, right? Similar thing. I'm gonna make it for what? For y equal to 5 as well, and hence I define the x to be like this way. So what I'm gonna get is 1, 5, 2, 5, 3, 5. Now if we combine everything together, isn't it the same thing like what we expected in the beginning, which is 1, 4, 2, 4, 3, 4, 1, 5, 2, 4, 3, 5, which is the 6 points. So why do I need this? Because once I have this, I can generate kind of like a linear space as well, but it's plane space on the XY plane. And then as long as I have my f function z equal to fxy, then I can just plug in this, these points, then I get a z, so that I can plot this surface, remember it? And that's why I need the mesh grid, okay? So let me close all the plotting again. So with this thing, now we can have a look at the plots. So this plot is nothing but actually a sphere. Excuse me. For a sphere, here's the parametric equation: r times cosine theta 1 sine phi. You will have two angles. One angle is the xy angle. The other angle is the angle, kind of like, how can I say? Let me. So one angle is this angle. This is on the xy plane. This is, for example, this is, let's say, y. This is x. So this is the angle, which is theta. And another angle is, suppose I have a line like this, and this is 3D, and this is a phi. Okay, so that's the meaning of kind of like, parametric equations, and this r is just the radius if you have a ball. Okay, now let me clear everything. So your x equal to this, y equal to sine, and z is simple, is sine, cosine phi. And then to make my life easier, I set up r equal to 1 so that I don't need to put an r there. And then let's see how to code this one. Let me use PyCharm still. What's the number? Scatter plot. Okay, let me create a new thing called scatter plot. Okay, again, let me just save my time, column paste. Now I'm gonna generate what? Generate the theta and generate the phi. Theta equal to np dot lane space, and then 0, 2 pi. How many did I generate here? 50. And then copy and paste for get a phi. Okay, now I have theta and phi. And then I'm gonna have what? The mesh grade theta phi equal to np dot mesh grade theta phi. Do you want to print it? It will be very interesting. Let's say I just print theta. That's gonna be 2D. I know it's gonna be very long. You see it? It's kind of like not 1D, it's 2D. So basically for, it's gonna generate span the whole space. The same thing here. And now once I have the theta pi after the mesh grade, I can simply just print everything. X equal to cosine theta times np dot sine phi. And y equal to sine np dot sine theta times np dot sine phi. And z is the easiest one, just np dot cosine phi. Okay, so this is xyz, and then I have x dot plot bigger, remember it, and add subplot. Again, even if you don't really have a subplot, you still need to, projection equal to 3D. And then I'm gonna have here, I believe I'll use a scatter. Yeah, because it looks like scatter. Yes, scatter plot. So I can use a scatter. By the way, here you cannot use plot. Why? Because as I mentioned here, plot can only take the vectors. Like a plot is these x, y, z must all be vectors. But here, after using mesh grid, this this x, y, z will no longer be one dimensional. Why? Because theta and phi are not one dimensional. I can simply just plot it, and just like comment this one print x. Let's say I can just x dot shape, which is either state. And you can see 50-50, see it? So x is 2D. And then if you use plot, it will immediately show you an error. We can test it. Let me first write the scatter. Ax dot scatter. And if you're not familiar, press shift in the table. Shift well, it didn't show anything. Anyway, I have no idea. It should show something here. X, Y, and Z. And then PLT dot show. So this should show you a ball. Here we go. So this is a ball. You can make it, configure and make it, axis equal so that it's going to be equal. Okay. Now suppose I don't use I don't use scatter. I use plot. It will immediately show you an error. Error. Don't tell me. Wait. Okay, here we go. Oh wait, sorry about. I forgot to close it. Let me run it again because I didn't close it just now. Didn't stop running. Okay, here we go. Error. And if you read the error message, which should be let me see where's the error message. And line set up broadcast to this MP operator cannot be broadcast together with the shape because you know why? Because it allows you only to take one-dimensional vector while your axis here is 2D. That's why it's wrong. Okay, now let's go back to scatter. And I can add something else, kind of like the set of labels, titles. Okay, let me run it because I will use this one a lot. So that I will need to make it kind of a bit better. X dot set X label. Y double to Y is equal, and then I can make X dot set title. Let's say 3D, let's say ball. Okay, here we go. Now we have the what? Well, no, now we have X label, Y label, Z label plus the title 3D ball. So that's the thing of this example. And then we can here scatter plot. Okay, yeah, here I've already mentioned this error. And we can make it a ball and also make it a surface as well. Let me call it instead of, let me rename it. Let me see, where's rename? Let me see, I cannot find a rename. That's interesting, huh? How can I rename my project? I remember Shift F6. Let me try it. All right, here we go. The shortcut is Shift F6, but honestly, I don't know. What if I do not remember it? How can I rename it? Anyways, let me call it a 3D, let's say ball 3D. Okay. And now we have this. And the next thing I want to do is a surface plot. So this is I just use scatter plot. Here's a 3D surface plot. What you need to do is just to change this one. Make it from scatter to plot surface. And we need to have a transparency what's called level alpha. So we just need to change this one. Plot surface. If you do not have alpha, I believe it's alpha equal to 1, which means it's not transparent. Yeah, here we go. And you can see it's completely not transparent, okay. Now let me make something to be 0.3. So alpha equal to 0 means it's completely transparent. Alpha equals to 1 means it's completely not transparent. 0.3 should be pretty transparent. You can see it. It's actually pretty transparent, So this is the surface. You can play with the alpha, whatever you want. This is a surface plot. The third thing I want to discuss is the contour plot. Again, similar. You just need to have a contour here. You just change this thing. All others are the same. But here you can define the density function. The 30 density function, it simply shows you how dense the contour lines are. So let me change it to be contour. Oh wait. Okay. And then I don't think you can run alpha, but let me try it. I'm just curious. Okay, the truth is you can run. Well, let's suppose my alpha is equal to 1, which means it's completely not transparent. And then suppose I will have the density equal to 30. Where it is. Okay, I have to. Okay, here we go. So this is density 30. What if I make it density to be, let's say, 10? Then you will have, let me see. I can make this FID equal to figure 1, PLT dot figure 1, sorry. And then I can have, let's say, FIG dot add FIG1. Or I just make my life easier. So in this case, I will plot 2. After all, okay. Let me directly just make my life easier. I can just compare like this way. So this is 10. You see the difference? It's not as dense as, let's say, let me make it to be 50. 60, it don't matter. You see, this is much denser. So with a bigger number, it's it's denser. So as the name, contour. And okay, let's run this one as well. This one is a real like a surface plane with contours projection. So the trick is, first of all, you will have the surface here. I believe this how do you read this one? Paraboloid. This is a paraboloid. And then these contours are actually just the contours, but you are gonna kind of like offset, you're gonna push it onto those kind of, I call it walls, because those things are the planes, kind of like, you know what I mean? Like here's the XY plane, here's the YZ plane, here's sorry, here's the XZ plane, and here is the YZ plane. So you basically want to push or offset those contour lines onto the wall. And the trick is here, you're gonna use the X limit, and you will set up an offset first, and then you're gonna use the X limit to control it. Okay, let's see how can we run it. Let me see. Here, a new file. What should I call it? Let's say surface plot with contours. Again, the first thing I need is those things. I'm gonna copy and paste here. And then since this is, let me see, since this is negative 1, positive 1, x equal to mp dot map, no, link space, negative 1, positive 1, 100, y is the same. Now I have x, y equal to mp dot mesh grid, x, y, and then z equal to x squared plus y squared. Okay. Now what we're gonna have, first of all, is to add a xplt dot figure dot add subplot, and then projection equal to 3D. And then we need to plot what? We need to first plot the surface, right? So x dot plus surface. Well, I don't have it. That's interesting. Plus surface. Let me give it an alpha equal to, let's say, 0.5. Here, I do need to set up the x and y, x, y, z labels because otherwise it's very easy to get something wrong. Z label and then y label. Okay. So for oh, that's a critical mistake. Okay, here we go. And we can see this indeed, this is x, this is y, this is z. Okay. And this is nothing, just paraboloid, paraboloid. I don't know how to read this word. The surface, pretty simple. Okay. Now, as a thing, how can we push those kind of contours onto the walls? So first of all, I can just plot the contour. Be careful. One thing is, see here. You know what? You'd better put the contour 3D here. Basically, if you write a contour similar because it knows projection equal to 3D, so that I'm talking about this one. Sorry about this because I just realized this point. Here, no, this one. So you'd better have contour 3D. Although you say contour, I've already told Python that it's a projection in 3D. Yes, it can do. But in many other things, contour 3D may have some special things. Like here, what we can do is we're gonna write the contour again, but we will need to write in. Okay, let me show how this is gonna happen. Let me just run it. Let's see. Okay. Well, you see something interesting. You see what I mean? The contour is the contour on this surface, but that's not what we want. What we want is the contour on the plane. So in this case, you need this Z DRI. So this shows you where you're gonna show the contour here. I'm gonna put Z DRI equal to X, and then run it again. Okay, run, just run it. Okay, here we go. Now I see the thing. Once I write this one, it just make things on through my x direction. You see it? That's my direction. It's gonna be just my x direction, but this is again not what I want. What I want is this: offset equal to -1. Oh, -1. So this tells me you are gonna put it onto the space. And under corresponding to this one, I need to set up this ax dot set x lim. Let me see, -1. Let me see, is it? Yeah, it's party one. And then in this case, let's run again. Stop and run. Let's run again. Okay, here we go. And you see, once I added this one, all these things were pushed to x equal to -1. You see what I mean? So it was originally here, remember, and I push it to this direction onto this wall, which is x equal to -1. So that's a thing. And you can do similar things to your y and z. And one more thing, remember, I have the cool warm color here. Let me see. Okay, I run a color map so that I need to import CM and the color map equal to this. Okay, so let me import from Matplotlib import CM. And this is just used for color map so that I can have something here. Color map equals to cm.cool_warm, I believe. Okay, don't give me anything. Cool warm up. Let me check it. I believe it's cool warm. Yeah, cool cm.cool_warm. And then you can just copy and paste and do this to all the other things. Here's y, here's z, and y is gonna be, oh, sorry, y is gonna be positive one. Why? Because you see here, you're gonna push it towards this direction so that it's gonna, for y, you're gonna push it to this direction, right? And this direction, see it? It's positive one here. So that you're gonna have clear y to be positive one. Okay, now this one's still here. So y is gonna be positive one. And how about z? Z, this direction is z equal to 0, so that you're gonna have z equal to 0. And a similar thing here, you have x lane, you need to set up for the y lane as well. Y lane is equal to -1, positive 1. And then let's run the code. Okay. Okay, here we go. See it? And that's how I can kind of like make it. I believe I set up a z as well. Oh, I set up z to be 0. Sorry about it. Here I should make it make it a z as well, so that 0 to 2, so that it will be kind of like a bit better. And that's also the reason why we set up. But by default, it's already 0. We just want to make it more accurate. Okay, here we go. And indeed, you can see, it is kind of like this way. And then, of course, you don't have to set up z to be this, but be very careful. If you set up z to this one, then your offset number in terms of z need to be changed. Otherwise, you will see something very interesting. Let me run it, and you will see. Let me manually close it. Otherwise, it will show error something again. Okay, if I keep, you see what happened here? This contour is in the air. Why? Because you make the z offset to be 0. So it tells Python that, hey, you just plot it on the contour on the z equal to 0 on the z xy plane, z direction, and hence this. To fix it, what you need to do is just to, because you set up z to be -1 too, so that you set up to be -1. And then this will fix the problem. Close it. Okay, now let me just run it again. So yeah, here we go. So you see, now everything's correct again. So this is a way how you can push those kind of contour lines by the offset, and then you need to coordinate it correctly with your limit setting, the limit setting. So that's the thing. For a better way, you can make it to be 3D, but again, it's not a big deal because you've already told Python the projection equal to 3D, so Python should understand. But it's just a habit, make it accurate. So due to the time limit, I need to stop here. Unfortunately, I didn't complete the whole lecture 5. So in the next lecture, we will finish this part and try to finish lecture 6 as well, which is the regression with some regularization parameter adjustment. So that's everything. Thank you so much for your time and have a good night. Bye-bye.